Let's take a look at what our linked list looks like right now. And what we see is we set up in this main, let's not worry about how things are done. So far, to set up a linked list, what we do is we set up a pointer to a node called head, set it equal to null, and then we can use insert to add things to that linked list. It just so turns out that it's going to be whenever we insert something, the way we set it up, we add everything that we add each data member or each piece of data to the front of the list, so that this goes to the front, then this goes to the front, and then this goes to the front, and so on, so that in such a way that when we're done inserting everything, it's backwards from the way it was in the array. So that's okay. We can live with that. We can change it later. What we decided was we wanted to keep things simple. So let's try this. Notice that now things are better. We don't have this big long links like head, arrow, link, and we can add any number of items. So let's try adding a few more. Let's say 8. Okay, so we have 6 things in our array. We're going to add all 6 and using our insert function. We're going to add it to the front of the list, and of course you can probably see you can change this around. You can insert into some other point in the list, but let's keep things simple. We're going to insert to the front of the list, and we're going to insert this value and cycle through all 6, and in the end when we print this out, it should print out all of these things, but I guess in the opposite order of how we insert things. So let's compile it, let's run it, and sure enough, there it is. So there's when we print the entire list, it just goes, it prints everything, but it goes in the opposite order. 8 first, then the 52, 4, so on. Okay, so essentially this works. Of course, we should probably fine-tune a few things. And also notice, every time we insert, guess what we're calling? Calling new. And remember, to avoid memory leaks, wherever you see a new, you want to see a matching delete. And it turns out there is no matching delete. And so, yes, this program does have a memory leak. But let's not worry about it so much. Right now, we're just trying to get linked lists set up to the point where we can understand and use it further. Okay, so let's take a look at the notes. And remember that there's a couple of ways to handle such data structures like linked lists. There's the C style approach, which is exactly what we've done so far. We kept it nice and simple. We use structs with everything public and global functions. So if you look at our data structure, here's our struct, everything public. We have 2 functions, insert and print. That's it. We're not really doing a whole lot. Of course, once you set up a linked list, you really should have all kinds of ways to search, to remove things. Now that remove is hard, and so we're not doing it just yet. Once we get done with the next step, I think we'll tackle some things like remove. So adding was easy, especially adding to the front of the list. Now if you have to do a remove, that gets a little bit complicated. Print was not so bad, even though it did have a loop. This is probably the simplest loop that we can write, and you will see that if you had to search, you would write a loop too, do the same kind of thing. You can probably see if you set this to search, and set the name of this function to search, and check if the thing that you're searching for is equal to the data member. Instead of printing in this case, just check if p arrow data is equal to this. Let's say we have a second parameter. Then if it's equal, then we have found the thing that we're searching for, and so on. And we can return true or something like that. Okay, so let's not worry about that. We're just going to set up some, in this case, just 2 functions. That's all we need to get started. And we know that this works. So we are using this first approach. Global functions, just 2 of them, structs with everything public. All right, so the next approach would be to use classes with private member variables, keep everything private. Even though structs can have private member variables, remember that our approach will be to use structs as if they were C-style structs, even though we are using C++ and we could have private member variables, right? And so linked list will use methods 1 and 2. Let's take a look at this and see. Take a closer look at this. Really, all we want is we have an array. We want to put all of those things into a linked list. So really what we want is something like this. Linked list. L. Let's say list. Okay, we create a linked list. And then what we would want to do is once we are all set up, we want to say list.insert. We don't care about where is the head node and all that. We just want to say insert. All right, and we want to say this. We don't care about pointers. Let's say if you want to set up a linked list class, this is how it should work. And once we are all done, we would want to print. So, and we don't want to figure out where the head pointer is. So the linked list class should keep track of that. So, of course, this doesn't work right now, but this is what I would like, even simpler than what we had before. I want to create a linked list by saying, and I can have it be statically allocated linked list object. So create the linked list, insert these data values, and for now we won't really worry about what order they'll be printed in. And then after when we're done creating the list, we want to print it. That's it. That's our basic linked list operations. So how can we accomplish this? So it turns out the book doesn't do it this way, but I want to show you how to do this. So I want to create a linked list class. Okay. And now I want to put this node struct in the private section so that the main class cannot access this this struct. Not only should it not have to deal with it, it shouldn't be even aware of this struct. That's data encapsulation. What do I want to make public? I want to have a constructor, all right, in which I will take on the responsibility of doing some of the things that we had over here. So for example, one of the first things we did was we said node star head, that is we declared a pointer of type, declared a pointer to a node and set it equal to null. So what we should do is put that in the constructor. That's the kind of thing we'd want to have in a constructor. Now we want to have a destructor, right? But it's going to be a little bit complicated, so I'm not actually going to create an actual destructor that does anything. I'm just going to keep it empty. All right, so now two things I need are the insert operation, and I'm not going to return anything. I'm just going to say void like it used to be. I'm not going to have the client tell me anything about pointers. The client should just tell me what the client wants to put in there. Okay, and so now it turns out since we have made this node a private struct inside this class, that type is still accessible to us, and we don't need to return anything. But here's what we need to do. Remember that in the way we had it just before, we would return a node pointer and we would set head equal to that. Well, you can just do that right here. Head is equal to temp. Okay, and we don't have to return anything. So if everything works, we will we'll create a new node, take this new data that the client gave us, set the linked data member equal to the head. It's just what we were doing in the previous version, and then set head is equal to temp. So now head points to this new node we just created. Essentially what that does is insert that node at the front of the list. So now this print method should not have any parameters, because what it should do is start at head, and then go down the list. Okay, so this should print everything, and finally we close off the class. Alright, let's see how many errors we got. Tons. Oh yeah. So one of the first things we forgot to do was we didn't declare this private data member head. Okay, how do we do that? Not so bad. We just say private node star head. Okay. Now let's compile this, and whoa, everything's gone. That was just that one problem. One thing that we were missing was that private data member head. Okay, so notice what we've done. We've gone from setting up all kinds of pointers with links, a whole set of links that we had to set up, and now this is much more object-oriented. We just say this linked list is going to take care of everything. All I have to do is call the insert method with a very simple interface. That is, you only have to pass in the thing that you're interested in saving. In this case, it's just an int, just so happens to come from an array. Okay, and then you call the print method and everything should work. Well, I'm not so sure it'll work, but let's try it. Compile it and run it. Well, I guess we were lucky. Everything just happened to work. I was hoping to have some errors that we could debug, but no such luck, no errors. Printed out everything in reverse order. And I'm guessing that everything just happened to work. We were lucky. So we initialized, so take a look at this class, this linked list class has a private struct. Now we could have made this struct visible. We could have put it out here outside the class. That would have been fine. Okay, that'll work too. So this is, if you want me to try that, here it is. Cut it, paste it, save it, compile it. It works, and then run it to make sure, and everything works. So you could have made the struct outside the class, but this is good encapsulation means that you should not reveal the details of your data structure to your client. So this main method is the main function is the client, and ordinarily this class would be outside. You'd have a linkedlist.h, linkedlist.cpp. You would have this class definition in the .h file, and then all the function definitions in the .cpp file. So that's ordinarily what we would do. In this case, I'm trying to keep everything all visible in one file, just so that it's easy for us to see. And I'm hoping that you've gotten enough practice to take a class like this, split it up into .h and .cpp files, and then still make it work. Okay, so I'm not doing it for this case, but I'm hoping that you can. Okay, so very nice interface. You just set up a linked list, use the insert method to add things, call the print method to print out all the data members.